All right, so here we got a application problem, and I think I'm going to do two applications instead of just one. So there's two left, this one and one more. So, a furniture manufacturing company manufactures dining rooms, tables, and chairs. A table requires 8 labor hours for assembly and 2 labor hours for finishing, and a chair requires 2 for assembly and 1 for finishing. Now, the maximum labor hours available per day for assembly and finishing are 400 and 120, respectively. Now, if X is the number of tables, Y is the number of chairs produced per day, write a system of linear inequalities that indicates the appropriate restraints on X and Y, and then find the set of feasible solutions graphically for the number of tables and chairs that can be produced. All right, let's write down what we have here. So we know that again, let's write down our variables. So X is equal to what? Tables, and Y is equal to chairs. And the assembly is going to be what? Less than or equal to 400. And then the other one is finishing. And that has to be less than or equal to 120. And tables require 8 hours assembly and 2 hours for finishing. And the chairs are 2 hours assembly and 1 hour finishing. All right, so let's put all these together. So we have then, it looks like what? 8x plus 2y has to be less than or equal to 400 to get the assembly, because assembly, assembly, and assembly. And then we have 2x plus y less than or equal to 120. All right, so now we solve both of these. Well, this one's easy. That's just y is going to be less than or equal to a minus 2x plus 120. This one we have to take over here, so we take the x over and we get y is going to be less than or equal to divide by 4 as a minus 4 or 2 minus 4x, and then plus divided by 2 is 200. Okay, so now we've got that. We've got that. Um, Now I think we need to have two more constraints. We're going to have x has to be greater than or equal to 0 and y has to be greater than or equal to 0, because otherwise it's not going to make sense making -5 tables or -5 chairs. And so we're going to have those two constraints as well. So those two, that, and that are the things that we need to plot. All right, so let's plot those. And because of that, we're actually just going to be over here in this right quadrant. Um, so we have a 120 and a 200. So the 200 is higher and it has a steeper slope. So it's going to come down something like that. The 120 is going to be a little less than half, and it's going to have a less steep slope. So it's going to come something like that. Now it's going to be again up in this quadrant here, so it's going to be less than the 120. So it's going to be down below this one, and it's also going to be down below this one. So to be down below both of those, that means we're going to be in this region here. All right. So that means we have to find this point, this point, this point, and that's 0, 0. So that's the easy one. All right. So again, this one is not too hard. What is that going to be? That's going to be 0, 120. This one, if we plug in y is 0, for that, then that's going to be what, 50, so that's going to be 50, 0. And if we plug both of them together, if we take that minus that, so that's gonna be 2, and that's gonna be 8, so that's gonna be what, 40, 40, I think. So I think those are our points. That's going to be our region we have. Now let's prove that's what we have for that last one though. So let's go back up here, clear that, clear that, clear that. And we had, what did we have? We had a minus 4x and then plus 200. Oops, 200. And we had a minus 2x plus 120. And now our windows are going to have to be a little bit bigger. So let's go up to, I don't know, 60. Let's go by 10. This one has to go to at least 200, so let's do 220. And let's go by, I don't know, 60 just for weirdness. All right, so that's what it looks like. And again, mine drawn looks a little different here. But what we need to do is we need to find the intersection point because that's the only one I wasn't sure about. Yeah, 40, 40. That one, I know we just plugged in y is 0. That one we plugged x is 0 and solved for the opposite. And then that's 0, 0. And that's going to be our region there. So that's how we get the solution to this one. And again, what we need to do is the set of feasible solutions is what's in that region. So anything you choose in here is a feasible solution to this problem. All right, so let's stop there and we'll come back for one more application and then we should be done.